I represent the data science team at OpenTable. How many of you have actually used OpenTable to make reservations? Oh, that's a fair amount. So we are very popular. Um, so before I begin, I just want to say that I used to be an astrophysicist before. Now I'm a data scientist, and the common thing that's between the two careers is Python and data. So I'm really indebted to the PyData community for making that translation pretty easy. Coming back to OpenTable, as you know, OpenTable is an app or a platform to make restaurant reservations primarily. So we connect diners with about 32,000 restaurants, both in the US and worldwide. And then we have a pretty nice set of traffic. So basically we seat about 15 million diners each month through our system. Our diners write more than 400,000 reviews every month. So that's, I can sort of start to see that over the lifetime of the company, we have accumulated a lot of data. But it's only recently that we're moving into data science and doing something with the data to enhance the experience of the diner. So essentially, there's this big move at OpenTable to move from being just a transactional company, which lets you book a table at a restaurant, to more of an experience company. So suppose you're walking and you want to find a place for dinner, you'll get recommendations for restaurants which are tuned or tailored to your tastes, not an alphabetical list. And also, like if you travel to a new city, the system knows about your preferences, so it'll suggest restaurants that are attuned to your taste. Also, you want to know about sort of what restaurants are about. So if this restaurant is a restaurant which is about amazing views and amazing seafood, and this is this other restaurant which is very meaty, it's about like barbecue and steak, you want to know that without having to go through, say, 2,000 reviews, right? So we have a ton of data in various different forms. I think when I think about the data we have, it's really like it covers the whole slew of data, kinds of data you can work on in data science. So we have the reservations, the transactional data. We have the search location where people are searching, where people are looking for restaurants. We have images of both interior of the restaurants and the food items. We have textual reviews. People write pretty extensive reviews on our platform. And the reviews are very sort of, because the customer has to go and actually eat at a restaurant and to write a review, they're much more believable. And then there are restaurant ratings. Obviously, people go and rate restaurants, and the ratings are also granular in the sense that people can rate food, ambience, service separately. And then there are menus that we have, and there are many other aspects of the data that we have. So it's a very rich data ecosystem that we live in at OpenTable. And the main sort of idea of going forward, what we want to do is to give you that magical experience of dining, and which really requires connecting the dots between understanding the diner very well and also understanding the restaurant. So basically, on the diner side, from your explicit or implicit interactions with our system, we want to build up a profile of you. On the restaurant side, we want to know what a restaurant is about, whether the restaurant is good for a date, or it's family friendly, or you're really into like restaurants with views. And so basically, it's basically a matching process between the diner and the restaurant. And all this comes sort of as a recommendation stack, but it has a lot more to it because there's so many different types of data that I already talked about. So there's textual data, there's like visual like images, and also basically there's also location. Like if you're a frequent traveler, we want to recommend differently than if you live in one place. So things like that. So basically I picked two themes for this talk because of limited time. So one is what we are doing with analyzing the review, the textual content that we have, and then also what we are doing in terms of making recommendations. And one is linked with the other, so I put them in that order. So we have a lot of reviews, as I said, and they come in all shapes and sizes. So there are very small reviews, like a single word called superb, And then there are reviews which might read like someone's biography. It's like really big and long and really like explains every aspect of the dining experience. So you have all these reviews, and so how do you make sense of reviews? So for example, Slanted Door, which is one of a very popular restaurant in San Francisco, it has like over 3,000 reviews. You're not going to go and read all the 3,000 reviews. But it turns out that whatever people are writing in their reviews, they can be summarized into themes. So people are not writing about 200 different themes in their reviews, but they're writing about the food, they're writing about the ambience, about the service. So there is this inherent sort of feeling or like structure of having themes around which people talk in their diner reviews. So for example, here are some sentences that I plucked from some of the reviews. So the first one, the first two which are in blue, you can pretty much see that it's talking about the food. But the second and the third and the fourth, they're basically talking about the Golden Gate Bridge views. It's only talking about the views. And the last one, it's talking both about the view and the food, right? And so, so think of now not in terms of sentences, but of reviews. Each review is sort of generated from what we call, data scientists call topics. And so you can think of a way in which a review is generated from a few handful of topics in a probabilistic way, right? And this is what is called topic analysis in the sort of machine learning parlance. So basically what we did was we looked at the corpus of reviews and we looked at first, broken down into geographic regions because we thought there might be regional nuances to the way people talk about things. And then we classify, we learn the topics which are inherent in the reviews through topic analysis, which I'll go into. And then you immediately see that these topics fall into categories like food, ambient service, and so forth. And then what you can do is you can go to a restaurant and see what topics are the highest weighted topics for this restaurant. So if you go to a restaurant which is situated by the bay and has amazing seafood, you will see the seafood topic and the view topic really bump up. But these topics are not being learned on a restaurant by restaurant basis. This is being learned from the global corpus of all the reviews that you have for that geographic region, right? And then what you can do is you can surface only the relevant reviews which is related to the topic you're interested in. So if you're interested in going out and eating meat, just click on the meat topic and it'll show reviews that are only relevant to the topic. So you don't have to go through the 2,000 reviews to see, like what people are saying about the meat at that place. So this is sort of the general idea of topic analysis. So what you have is, every document is sort of generated probabilistically from certain topics, and each topic is a probabilistic distribution over words, basically. And without going too much into detail here, so essentially think of like, a review that's talking about seafood and views. There are two topics out there which is about seafood, which is about views, and the words are sort of being probabilistically generated from those, and you're getting the review in the end. So you basically apply this backward, and from the reviews you go back to the handful of topics that have generated all the reviews on our system, sort of. So this is there's a way of going after it through non-negative matrix factorization, and for that the Python has amazing tools already. So we basically used Pandas, scikit-learn. There's a tool called gensim, which lets you do latent Dirichlet allocation, which is one of the main ways of learning topics. And then there's the nltk, which is the natural language toolkit, which lets you do stemming and lets you do all kinds of fun stuff before you actually put that into a topic learning system. And some of these techniques we are also porting over to Apache Spark. So this is like how you can learn topics in 3 lines. So basically, get your data, do a count vectorizer using scikit-learn. Then you basically transform your reviews into bag of words model. I actually do a TF-IDF, if you know what that is, before I get into this step. And then you just call decomposition.nmf. And out comes this like topic matrix, which is essentially number of documents by topic weights. And then you have this other matrix after this decomposition, which is topics by words. So every topic is a distribution over words. And here I'm showing some of the topics that come out in the SF Bay Area. So you can see the first one is about fish and chips and tacos. The next one is about ambience. It's saying noise level is very difficult to hear, conversation. The third one is about Bay Bridge, moonlight. So it's like about views. The server was knowledgeable or helpful. Then there's the sushi topic by itself. Parking being difficult or easy. There's valet parking. There's a Sunday brunch topic, the crab cake topic, anniversary wedding special occasion topic, right? So we learned about 200 of these topics, and then we categorized them into food, drinks, ambience, value, service, special occasion. And there are some generic topics which has to only deal about I went to a restaurant, right? So we throw them out. Then we can have these really nicely categorized topics, and then we can do various things with these topics. So first thing I looked at was whether there were some regional variations between the topics we learned. So you can basically see that if you look at the view topic, like the San Francisco Bay Area is very much very well endowed with views. So you get more than one topic that talks about views there. Whereas in Chicago, people are talking about basically looking out over the lake or look from like some tall building. And in New York, people are talking about the views of the Hudson River. In London, it's a Thames Bridge, the St. Paul Tower. So basically, there is a lot of nice stuff that you can learn just from looking at the topics. For example, there is a thing in UK called Sunday roast, which you don't find in the US. So US people talk about Sunday brunch, right? And then people talk more about wine pairings in the US, whereas they talk about wine matching in the UK. So it's kind of really nice how natural language is people refer to the same thing in different ways in different places. And then in the UK, there's a topic on Indian food by itself, which is not very surprising, right? So you can actually go to a fine dining place through OpenTable and have Indian food, which is not that prevalent in the US. And then there's the Yorkshire pudding topic and all this, and people go to, restaurant pre and post theater. So that's the theater topic there. And obviously in the UK, there's the afternoon tea, right? So you get all these things, coming out from this simple exercise of doing topic analysis. And then you can look at all the topics that's visiting your restaurant, the single restaurant, and you can do a weight over the topic distribution of that restaurant. And you can say, oh, this restaurant here is about, this prime rib and rib eye. It's very meaty restaurant. And, maybe, there are 10 topics that only make sense to this restaurant. The service was pretty good. The noise level was very high. And then you can only surface the reviews when you say, when you're only interested in the prime rib topic, it will only, surface the reviews that's relevant to that. So it's a very nice way of pruning through the topics. But we went one step further and we said, are there dishes? So basically from these topics, we can also learn about what people are talking about in terms of dishes. They mention a lot in the reviews. If there are dishes which are very, very regional that you don't find anywhere else, so basically think of this as a set subtraction. So you have the set of all foods that's sort of global, and then you subtract it from it all the foods that's in all other cities except this city, and you're left with something which is very indigenous to this city. Here I'm the example I'm giving is Toronto. There you can find something called flower pot bread. So basically they actually bake the bread inside a flower pot. There's a duck poutine pizza, which is served a heart attack served on a pizza, but must be delicious. So basically I'm just trying to exemplify how starting from just a simple concept of learning some topics, you can take this in various different ways and make it very engaging, right? And then if you look through UK, in Edinburgh, of course, haggis makes a lot of, has a lot of weight in there. And you can see nicely that, in the south of UK, people are more talking about seafood and fish, whereas, in London, it's more about amuse-bouche and all the sort of very fine dining kind of things. So from this kind of topic analysis, what we wanted to do is to find dishes that are mentioned a lot of times in the reviews, and then basically find out what are the popular dishes at this restaurant, right? So the way we went through this exercise was we took the food topic. So you could just think of doing an n-grams count, right? So I go to the review and I see which n-grams, which three-letter words are repeated many, 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 many times. But there is no guarantee that those three-letter words would be about food. So we could descope the words that visit, that vocabulary by actually taking the words that fall in the food topic, because you already categorized the topics as being food, and then learn the most frequent n-grams that are within that set of words. And from that, we got a huge amount of dish tags, like like crab cake appetizer, flourless chocolate cakes. These just come out of this analysis, and then we have a way of sort of like mechanical turking the false positives out. So you get a very nice. So we had already a very nice list of n-grams, but this significantly improved and expanded the vocabulary that we started with. And now we can do this. So this is within the OpenTable app, where you can actually go to, so this Bulut Sud is a restaurant right here in Manhattan, and you can go there and it'll show you these are the popular dishes. And then for each of these dishes, you can link back to a menu, a review, where we can see what people are saying about that dish, right? So this is a very nice way of sort of summarizing the restaurant to you and giving you a sense of what this restaurant is about. But dishes are not the only things about restaurants. You care about the ambience, you care about other attributes. So we basically came up with a finite set of attributes that we wanted to learn, and then we go in the reviews and we apply logistic regression to learn what sort of attributes people are talking about in the reviews. And it's the same restaurant again, and it says it's known for pre-free menu. We have a great service. It's good for birthdays. So this is a nice way of summarizing the entire restaurant to you without you having to read all the review content, right? And the sort of devil is in the details, because sometimes it's not very obvious what people are saying in the reviews. So these kind of machine learning algorithms has to be smart enough to say something like, when someone says, "I love the relaxed feel. It's dark, small, cozy." Dark can be a very sort of negative word, but it sort of figures out that the person is talking about dim lighting, right? So it's basically by learning sort of how people use these words when they describe certain things. And then you can also, if I know nothing about you, but if I only know the restaurants you have visited over your lifetime, I can build up a profile of you just by looking at the attributes of those restaurants. So this is our CTO, Joseph Esas, and I made a profile of him. So he visits restaurants which are fit for foodies. He's a foodie, and he obviously does a lot of business meetings. So there's good for business meeting is one of the attributes in the restaurants he goes to. He goes mostly to kosher restaurant that comes up in sort of the restaurant metadata of the restaurants he visited. So from this, you can also start building up sort of a profile of the user. And then, you can go one step further and look at the reviews and see what are the sentiments people are expressing, and what are sort of the ingredients of a very stellar review. So we took all the awesome 5-star reviews, and we asked, what are the predictors of a good review? What words do people use when they're actually giving a restaurant 5 stars, right? And you see, it's recommended is a big word. Excellent, I recommend. Definitely delicious, presented very beautifully. So you can sort of, if you look at it, you can see this is, these are the ingredients of a very good review. And then you can flip it, and you can also say, what are the ingredients of a very bad review? And you'll see that salty is not a very obvious word, right? But salty comes up a lot when people talk about a bad review. Obviously disappointed, service was slow, waiting for a long time, and this other word which is okay. Food was just okay, so you say okay, 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 it comes up. So basically, just by digging into the textual information that we have, we are seeing all these very nice insights, right? And I just wanted to leave you with a taste of what kind of stuff we can do with just textual data. So moving on, so we don't want to just stop at learning what restaurants are about and what users are about, but we want to connect the two. So we want to connect restaurants with users or with diners. So essentially, what are the ingredients for a recommendation engine at a place like OpenTable, right? So you have the diner-restaurant interactions. So previously you dined out, you gave them some ratings, or you searched for some restaurants on our system, or you left reviews, and many more. And then there's cuisine, the price range of the restaurant that matters to you. Maybe you'd never go to a very high-end restaurant. The location, and what are the topics of these restaurants. So if this restaurant is about seafood, or if this restaurant is about romantic atmosphere, might be important to you. And then there is the user profile, kind of what I talked about, is what sort of your demographics are and those things. So traditionally, collaborative filtering is the way to go for doing recommendations, but there are a bunch of approaches here that I've enumerated. So there's the nearest neighbor approaches, where you find users that are similar, or restaurants that are similar there's a content-based approach because you know so much about the restaurants that even if you have visited only 2 restaurants, we can surface similar restaurants to you. And this is very useful for cold starting a set of people who have very little interaction with our system. And then finally, what we're building right now are factorization machines, which can actually include all these things in like one nice uniform formulation. So if I don't know how much time I have, I probably have 5 more minutes. So I'll just go through quickly. So everyone knows about collaborative filtering, I'm sure. So basically you have the explicit case where you have actually left a certain rating for a restaurant, and then you have many restaurants you haven't interacted with for which you want to know the predicted rating. And typically what you do is basically break it down. You do a matrix factorization kind of approach. You break it down into n diners by n factors and n factors by n restaurants matrices. But the factors are really like, say, maybe 200 or so. So the idea being that each of these factors are latent reasons why you went and gave that restaurant a 5-star. And then once you multiply it back, it fills in the missing cells in this matrix. And then you can rank them by the ratings and recommend the top ranked items. Right? So that's how it works usually. But, we don't, we have ratings from people, but we have many other signals. People search for restaurants, right? And so that's where the implicit preferences come in. So basically, the fact that you're searching for a restaurant, say, 50 times, is a signal to me that you really want to go there. You really probably want to, you like that restaurant. And so then it becomes sort of an implicit preference formulation. And there's a very, it's a classic paper, which is like Hu, Koren, and Volinsky, which we have implemented at OpenTable, which is basically take the actual raw count and take a 1 plus alpha times Rij, which is we call a confidence. So basically, all we're saying here is that the fact that this person has searched for this restaurant gives me a preference, one, that this guy has a preference for this restaurant. But how much you weight that when you learn the latent factors is given by the confidence. So if you have searched only like 5 times, I give you much lower confidence to get that right than if you've searched for something 500 times, right? And this is a very nice approach. So we have implemented this. So first we, obviously massage the data sets with a lot of Pandas and Python tools. But finally, it goes into a Spark machine learning library called MLlib. It's a very nice library. So if you're using Spark, it's a very powerful tool. And we use the alternating least squares algorithm to learn the latent factors. We optimize for precision at k, because we are inherently doing a ranking algorithm here. So we're ranking by preference. But then what do you do with the users who have very little interaction with our system, right? So if this guy went out only 2 times in their OpenTable lifetime, all they're going to get out of a collaborative filtering is mostly noise. So for those people, we came up with this content-based recommendation system. So suppose this guy went out to mediocre Indian restaurants 2 times, the only 2 times he booked through OpenTable. So what we can do is we can learn, so because we have all this metadata about the restaurants, we know what the average star rating is. We know it's an American restaurant here, in a financial district. We know the location. We know the price range is $31 to $50. It's a pretty pricey restaurant, right? And we know the ratings over all these granular aspects like food, service, ambience. We also know the attribute tags of the restaurant, that this is fit for foodies, it's a special location place. So for every restaurant, we have this information. So given that this guy has gone to 2 mediocre Indian places, we can basically surface more mediocre Indian places to this guy, right? But suppose you're this other guy who goes to high-end French places, but only like cheap sushi places, right? So because we have this metadata, even from those 2 interactions, I can surface a mix of the 2 kind of restaurant. And also the way it learns, so we use a Bayesian approach, like some information retrieval approach. It does not actually stay within the cuisine that you visited, but it also weights the other aspects. So maybe you went to that French restaurant because it had amazing ambience, which was romantic. So then it will actually surface a few more romantic restaurants, even if they're not French. So that's kind of what we do. And we see lift in A/B tests and stuff with doing that. And finally, we are using sort of building factorization machines. So I don't know how many of you have used this in recommendations, but this is a very, very powerful way of including side features into recommendation system. So here, instead of having one matrix, which is user and items, and then the cells are values, you basically, unravel the matrix into this huge matrix where you have 1, 0, 0, 0 as being the user, and the second in the orange is the restaurant in our case, right? And then the third and the fourth blocks can be things you know about the user, things you know about the restaurant. And at the end, the target is the preference that you already know for this user item interaction. And then you can throw them all in, and essentially what it does, it's basically a logistic regression in the end. But before doing that, the trick is, because these matrices can get really, really big, right? Because suppose you have 3,000 restaurants and who knows, 10 million users. So each of these rows will become that long, right? So what it does, it actually factorizes each of these rows into smaller latent factors first, and then it uses those factors to learn the prediction. That's why it's called a factorization machine, and it has been shown to work. It's like won several Kaggle competitions with this. So the challenge here is, taking this. So there is a library called libfm, which you can go and download and use. It's a C++ library. But the problem is it's written for an academic scale data set. And it does training and testing at the same time. And there's no way to store the models and use it later. So we are actually breaking into the code right now. And we, basically found out a way of saving the models. We're using the MCMC approach in there. And then sometimes you get these amazing, nice moments of joy when you can write all those equations in this one line of Python code using SciPy sparse operations. It's kind of cool. So you can do the prediction of the entire set in just one line, which is kind of cool. But to scale it up to the sort of, say, the entire US for us, we are porting over the factorization machine to Apache Spark. We are actually also partnering with Databricks Clouds, which is a cloud platform that lets you use the Spark within sort of a notebook-like environment, which has been really useful for us because as you develop, you want to see. So basically, imagine you're running an IPython notebook over your entire data set in EC2, and having and doing all the operations over RDDs, which are basically like memory, storing the data up in memory. It has been pretty useful for us so far. So things that we want to do in the future is more on the sentiment analysis, on the reviews. We want to do what's trending in a certain city at a certain time, so we can like really give you like basically you can get an email saying, oh, kale is trending, right? Go and get, or Dungeness crabs are in town. And then, and obviously a full recommendation stack would be something like an ensemble of all those models that I talked about. So we are getting there. If I'll just take 1 minute to, advertise this. So I'm a member of this organization called Bayes Impact, which is a non-profit, which is trying to use data science for social good. It's got a lot of traction recently. So if any of you are interested in working on problems, some of these problems are, one finished project is Parkinson's disease stratification of patients, improving organ transplant outcomes. There's a very, very nice, impactful social problems that we are working on with the healthcare, with the government directly. So just reach out to me if you want to contribute, or basically they provide a fellowship for you to go there and work with them for 6 months to a year and work on a social problem, which is really awesome. So with that, I'd like to thank you.